Before anyone looked through a telescope, before anyone understood what Saturn really was, a story had already begun. It started around 400 million years ago. On Earth, dinosaurs already ruled the land, completely unaware that, far beyond the reach of their world, two moons circling Saturn were racing toward one another. When they finally collided, the impact was unimaginably violent. In a single cosmic instant, it changed the future of an entire planetary system. The consequences of that collision would remain hidden for hundreds of millions of years, until scientists in the modern era finally pieced together what had happened. But before we uncover how this incredible story unfolds, take a quick moment to subscribe to the channel. We're on the journey to reach 1,000 subscribers, and your support truly helps us continue bringing you fascinating stories like this. Now, let's continue. For generations, Saturn's magnificent rings were believed to be ancient. They were thought to have formed alongside the planet itself, surviving almost unchanged since the birth of the solar system. That explanation seemed perfectly reasonable, and for centuries, hardly anyone questioned it. Then Cassini arrived. After spending years exploring Saturn from close range, the spacecraft returned measurements that completely overturned everything astronomers thought they knew. The rings were not billions of years old at all. Instead, they were astonishingly young, only a few 100 million years old. That meant they had appeared long after Saturn itself had formed, and even long after dinosaurs had begun roaming Earth. The discovery solved one mystery but immediately created another. If Saturn's rings were not ancient leftovers from the birth of the solar system, where had they come from? For years, no one had a satisfying answer. Then, in February of this year, a new study offered a remarkable possibility. It told the story of an ancient chain reaction, one driven by gravity, orbital resonances, and an extraordinary collision that unfolded in what amounted to a mere heartbeat on the timescale of planetary history. Standing at the center of that story was Saturn's largest moon, Titan. To understand how Titan became the key to the mystery, the story has to travel much further back, not hundreds of millions of years, but more than 4 centuries. In 1610, Galileo Galilei turned his telescope toward Saturn, becoming the first human being ever to do so. What he saw made almost no sense. The planet appeared to have 2 enormous companions attached to its sides, giving Saturn the strange appearance of having giant ears. Then, 2 years later, those mysterious companions vanished completely. Even stranger, another 2 years passed before they returned, now resembling curious handles or arms stretching away from the planet. Galileo had no way of knowing what he was actually looking at. His telescope, revolutionary though it was, simply lacked the power to resolve Saturn's rings clearly. Instead, he was unknowingly watching the changing angle from which Earth viewed the ring system. Saturn spins with its axis tilted by about 27 degrees. As the planet slowly journeys around the Sun, the rings alternately tilt toward Earth and then away from it. At certain points, they become so thin from our perspective that they almost disappear entirely. That was exactly what Galileo had witnessed. Nearly half a century passed before telescope technology advanced enough to reveal the truth. In 1659, Christian Huygens finally solved the mystery. The strange handles Galileo had struggled to explain were not separate objects at all, but one enormous continuous ring surrounding the planet. During those same observations, Huygens also discovered Titan, Saturn's largest moon, unknowingly introducing another major character into a story that would not fully unfold for centuries. As the decades passed and telescopes steadily improved, Saturn continued revealing more of its secrets. Jean-Dominique Cassini, expanded the growing family of known moons by discovering Iapetus, Rhea, Tethys, and Dione. Then, in 1675, he noticed something equally remarkable: a dark gap cutting directly through Saturn's rings. Today, that feature still bears his name as the Cassini division. Even then, astronomers still misunderstood the rings themselves. Many imagined they were solid sheets circling the planet. It was not until the 19th century that James Edward Keeler demonstrated this could not possibly be true. Instead, the rings had to consist of countless individual particles, each traveling independently around Saturn in its own orbit. That revelation transformed scientific understanding once again. But the real surprises were still waiting. Everything changed during the late 20th century. First came Pioneer 11. Then the twin Voyager spacecraft swept past Saturn, each returning clearer images than the last. When Voyager 2 completed its flyby in August 1981, it exposed a breathtaking level of complexity that nobody had previously imagined. What once appeared to be broad, simple rings were actually composed of millions of incredibly fine ringlets, woven together into one of the most intricate structures anywhere in the solar system. Yet even Voyager had only begun to reveal the truth. The greatest chapter of Saturn's exploration arrived with the Cassini mission. For more than a decade, the spacecraft lived alongside the giant planet. It threaded its way through gaps in the rings, skimmed close to their outer edges, and, during its unforgettable final mission, repeatedly plunged through the narrow space between Saturn itself and its innermost ring before sacrificing itself in the planet's atmosphere. Every pass delivered another piece of the puzzle. Cassini transformed Saturn from a distant, beautiful object into one of the best understood planetary systems in the solar system. It revealed extraordinary detail while uncovering a mystery nobody had anticipated. The rings themselves turned out to be astonishingly thin, ranging from only about 10 meters to roughly 1 kilometer thick, depending on where they were measured. And that unexpected discovery was only the beginning. The story continued as Saturn slowly revealed more of its secrets. Over the years, Jean-Dominique Cassini expanded the growing family of known Saturnian moons by discovering Rhea, Tethys, Dione, and Iapetus. Then, in 1675, he noticed something no one had ever seen before: a genuine gap slicing through Saturn's magnificent rings. That dark opening would forever bear his name as the Cassini division, becoming another piece of a puzzle that would take centuries to solve. Even with those discoveries, astronomers still misunderstood what the rings actually were. Many imagined them as vast solid sheets encircling the planet. That picture survived until the 19th century, when astronomer James Edward Keeler carefully demonstrated that such a structure simply could not exist. Instead, the rings had to consist of countless individual particles, each traveling around Saturn independently in its own orbit. The elegant simplicity of a single ring gave way to something far more dynamic. Still, the full truth remained hidden. Everything changed during the late 1970s, when humanity finally sent spacecraft to visit Saturn in person. Pioneer 11 arrived first, followed by the twin Voyager probes, each mission returning images sharper than the last. Every new photograph peeled away another layer of mystery. Then, in August 1981, Voyager 2 made its historic flyby and revealed something almost impossible to imagine. What had always appeared from Earth to be a handful of broad rings was actually an unimaginably intricate system made up of millions of tiny ringlets woven together with extraordinary precision. The closer scientists looked, the more complex Saturn became. But even Voyager had only opened the first chapter. The real breakthrough arrived with the Cassini mission. For more than a decade, the spacecraft lived alongside Saturn, weaving through gaps between the rings, skimming their outer edges and sending home an endless stream of astonishing discoveries. During its dramatic finale, Cassini repeatedly dived through the narrow gap separating the planet from its innermost ring before deliberately plunging into Saturn's atmosphere, ending the mission forever. By then, it had transformed humanity's understanding of the entire Saturnian system. Cassini showed that Saturn's rings were astonishingly thin, varying from only about 10 meters to roughly 1 kilometer thick, depending on where they were measured. Yet those remarkably thin rings stretched across an immense distance of nearly 282,000 kilometers from the planet. As astronomers mapped them in greater detail, they organized the major rings alphabetically in the order they had been discovered. They became known as the D, C, B, A, F, G, and E rings. Far beyond them, near the orbit of the moon Phoebe, lay one final, incredibly faint structure now known as the Phoebe ring. The rings themselves were far from isolated. Tiny shepherd moons quietly guarded them, using their gravity to keep countless particles confined to their delicate paths. Pan, Daphnis, and Prometheus traveled directly within the ring system, while Pandora, Janus, and Epimetheus orbited just beyond the outer F ring. Much farther away, Mimas, first discovered by William Herschel in 1789, exerted a surprisingly powerful gravitational influence over the entire ring system despite its relatively modest size. Meanwhile, Saturn's family of moons kept growing. When the Cassini mission came to an end, astronomers had confirmed 62 moons orbiting the giant planet. Improvements in ground-based telescopes and modern sky surveys continued adding new discoveries. Today, the confirmed total has climbed to nearly 300, with new moons still being identified, giving Saturn more known moons than any other planet in the solar system. Together, they form one of the most extraordinary collections anywhere in space. Some are large, regular moons circling close to Saturn in nearly the same orbital plane. Others are distant, irregular worlds traveling along highly tilted, eccentric paths. At the smallest end of the scale are curious, ravioli-shaped ring moons, slowly collecting fresh material around their equators as fine dust from Saturn's rings settles onto their surfaces over millions of years. Cassini also answered another fundamental question. It revealed exactly what Saturn's rings were made of. Almost all of the material, around 99.8%, turned out to be water ice. The individual pieces ranged enormously in size, from grains smaller than sand to icy blocks as large as mountains. That abundance of brilliant ice explained why Saturn's rings shine so brightly, even through relatively modest telescopes on Earth. Then came another surprise. Using Cassini's measurements, scientists calculated the total mass of the entire ring system at roughly 16 quadrillion tons. That sounds enormous until it is placed into perspective. Altogether, the rings contain less than 0.02% of the mass of Earth's moon. It was an astonishingly small amount of material spread across one of the solar system's most spectacular sites. That combination of facts, the rings' extraordinary brightness, and their surprisingly tiny mass, forced scientists to ask a question no one had seriously considered before. And that question would eventually lead to one of the most remarkable discoveries in Saturn's history. That question did far more than challenge an old assumption. It opened the door to one of the most important discoveries ever made about Saturn. Scientists knew that space is never completely empty. Over millions of years, tiny micrometeorites continually strike exposed surfaces, while drifting cosmic dust slowly settles onto them. Bright water ice, no matter how pure it begins, gradually becomes darker and dirtier under that constant bombardment. That simple fact created a problem. If Saturn's rings had truly existed since the birth of the solar system, why did they still appear so brilliantly bright? Cassini had already supplied another crucial piece of evidence. Because the spacecraft had measured the ring's surprisingly low total mass, researchers could estimate how much dust would be needed to noticeably darken that amount of icy material. From there, they could work backwards and calculate how long such a process should take. The answer was astonishing. Everything pointed toward the rings being incredibly young, most likely forming somewhere between 10 and 100 million years ago. Compared with the solar system's 4.6 billion year history, that was barely an instant. The conclusion overturned decades of accepted thinking. Before Cassini, many astronomers had genuinely believed Saturn's rings had always been there, forming alongside the planet itself billions of years ago. Instead, the evidence suggested something remarkable. By the time Saturn's rings appeared, dinosaurs had already been roaming Earth for roughly 150 million years. That revelation immediately raised the next mystery. If the rings had not existed since Saturn's birth, then where had they actually come from? Curiously, the search for an answer had begun long before spacecraft ever visited Saturn. Back in 1849, Edward Roche was trying to understand why spectacular ring systems seemed to exist only around the giant planets. He realized that gravity could sometimes become destructive rather than protective. The same tidal forces that raise Earth's ocean tides could, under the right conditions, become powerful enough to overcome the gravity holding a moon together. In Roche's picture, any moon that wandered too close to its planet would be pulled apart piece by piece. Instead of remaining a single world, it would be shredded into countless fragments that continued traveling along nearly the same orbit, gradually spreading out into a ring. From that idea, Roche calculated a critical distance. If a moon crossed inside roughly 2.5 planetary radii, measured from the planet's center, it could no longer survive intact. That invisible boundary would later become famous as the Roche limit. For Saturn, that distance works out to roughly 87,000 kilometers, remarkably close to the outer edge of the planet's F-ring. As Cassini continued returning data year after year, more and more evidence pointed toward a startling conclusion. Something catastrophic had happened inside the Saturnian system long after the planet itself had formed. In 2022, a team of researchers from MIT proposed an explanation. They suggested that Saturn had once possessed another moon, orbiting between Iapetus and Titan. Although no trace of it survives today, they named this hypothetical world Chrysalis. According to their model, Titan's immense gravity slowly disturbed Chrysalis's orbit over millions of years. Eventually, the moon drifted dangerously close to Saturn. Once it crossed the Roche limit, Saturn's tidal forces would have torn it apart, scattering its remains into orbit and creating the rings we see today. It was an elegant solution, but the story did not end there. When researchers at the SETI Institute recreated that exact scenario in far greater detail, publishing their results in February of this year, they discovered something unexpected. Their simulations suggested that a moon like Chrysalis would have been far more likely to collide directly with Titan than to drift close enough to Saturn to be ripped apart. If that happened, most of the debris would never become rings at all. Titan's enormous gravity would capture much of the material, while the rest would simply escape the Saturnian system altogether. Very little would remain to build the magnificent ring system visible today. As astrophysicist Matija Chuk and his colleagues continued running their simulations, another mystery kept appearing. Again and again, Hyperion behaved in a way that made no sense. This small, oddly shaped moon, famous for its chaotic tumbling rotation, was repeatedly thrown completely out of the Saturnian system in most of their simulated scenarios. Yet reality told a different story. Hyperion was still there. Not only had it survived, but it continued orbiting Saturn today, locked in a stable orbital relationship with Titan itself. That contradiction would soon become the clue that changed everything. The more Mattia Chuk and his team refined their simulations, the stranger the story became. In scenario after scenario, one particular moon simply refused to stay where it belonged. Hyperion, Saturn's oddly shaped, constantly tumbling satellite, kept being thrown completely out of the Saturnian system. In the overwhelming majority of the simulations, it simply disappeared into space. There was only one problem. The real Hyperion was still there. Anyone could point a telescope toward Saturn and confirm that the moon continued to orbit the giant planet. Even more intriguing, its orbit was locked into a stable relationship with Titan's own path around Saturn. That contradiction became the turning point. Chuk realized that the Titan-Hyperion orbital relationship itself appeared to be surprisingly young. Its age matched almost perfectly with the period when the hypothetical moon Chrysalis would have vanished from the system. Suddenly, Hyperion no longer looked like an unlikely survivor that had somehow escaped an ancient catastrophe. Instead, it began to look as though it had actually been born from that catastrophe. That single insight changed the direction of the entire investigation. Rather than treating Saturn's many mysteries as separate problems, Chuk and his collaborators began looking at the Saturnian system as one enormous interconnected story. They combined Saturn's unusual 27-degree axial tilt with the behavior of its moons, their orbital relationships, and the evidence gathered by Cassini, searching for one sequence of events capable of explaining them all. Piece by piece, the puzzle started fitting together. Their simulations suggested that Titan had not collided with a moon the size of Chrysalis after all. Instead, it most likely struck a much larger world, roughly 4 times more massive than the original hypothetical moon. The team named this lost object Proto-Hyperion because the modern Hyperion would eventually emerge from the aftermath of that same collision. Titan itself would have looked very different at the time. It would have been noticeably smaller than the Titan we know today and traveled around Saturn in a far more circular orbit. The simulations proved remarkably consistent. Out of 60 complete simulation runs, Proto-Titan collided directly with Proto-Hyperion in 42 of them. In most of the remaining scenarios where no collision occurred, either Proto-Hyperion or Iapetus was eventually flung entirely out of the Saturnian system instead. The researchers concluded that the collision most likely happened around 400 million years ago. From that single moment of destruction, an extraordinary chain of events began unfolding, one capable of explaining many of the Saturnian system's most puzzling modern features. But how could one collision reshape an entire planetary system? The answer lay in something astronomers call resonance.